In this section, we're going to look at other types of equations. We're going to look at equations containing higher degree factorable polynomials, equations with algebraic fractions, equations that have radicals in them, equations with fraction exponents, and also quadratic form equations. The first example we're going to look at is the equation 2x to the fourth minus 3x cubed equal negative x squared. This is an equation that's a polynomial of higher power, but it's factorable. Before we can factor and solve, however, we have to move all the terms to one side. So we have our original equation. We want to add x squared to both sides. And this gives us 2x to the fourth minus 3x cubed plus x squared equals 0. Now we do this so that we can eventually use the zero product law. Our next step is to factor out what we can factor. In this case, an x squared factors out. We get x squared times the quantity 2x squared minus 3x plus 1 equals 0. Now we can let each of these factors equal 0. We get x squared equals 0, and we get 2x squared minus 3x plus 1 equals 0. Well, x squared equals 0 is pretty easy to solve. Extract square roots and you get x equals 0. Plus or minus 0 actually, but that's still 0. The other equation is just a typical quadratic, and it happens to factor. It factors as 2x minus 1 times x minus 1 equals 0. Now we apply the zero product law again. We let each of those factors equal 0. We get x minus 1 equals 0, and also 2x minus 1 equals 0. Solving both of these equations gives us x equal 1 and x equals 1/2. So we end up with three answers: x equals 0, x equal 1, and x equal 1/2. Now we're going to solve an equation that has algebraic fractions, or what are sometimes called rational expressions. Our equation is 2 over x minus 1 minus 1 over x equals 3 over x squared minus x. Now what we have to do here is clear out these fractions, and in order to do that we have to figure out what's the least common denominator. Well, before we can even do that, we have to factor all the denominators. The denominator on the right, x squared minus x, factors as x times x minus 1. We factor the x out. Now we look for the common denominator. Well, it has to contain all the denominators as factors. So we need an x and we need an x minus 1. So our least common denominator is x times x minus 1. Now we multiply both sides of this equation by that least common denominator. And when we do that, we're going to end up canceling out all the denominators and have an equation that has no fractions in it. So we do that in the next step. We multiply both sides, and by the distributive property we have to multiply each and every term. So on the left we multiply 2 over x minus 1 times x minus 1. And you can see the x minus 1's cancel. We multiply 1 over x by x times x minus 1, and the x's cancel. And on the right side we multiply 3 over x times x minus 1 times the x minus 1, and then the entire denominator cancels out. And all we have left is 2 times x minus 1 times x minus 1 equals 3. And that's our next statement here, our equation, which is simplified by quite a bit now. 2x minus 1 times x minus 1 equals 3. We can simplify that by rewriting as 2x minus x plus 1 equals 3. Remember to switch the sign because we're multiplying -1 by -1. And we combine like terms and we get x plus 1 equals 3. Well, this has a solution of x equal 2. We have to always check these solutions, however. Sometimes we'll get an answer that when we plug it back into the original equation, you get division by 0. But in this case, that's not what we get. When we plug in x equal 2, we end up getting 2 over 1, or 2, minus 1 over 2 equals 3 over 2. Well, 2 minus 1/2 is 1 1/2, which equals 3/2. So x equal 2 is the solution. In this example, we're going to solve an equation that has a radical in it. We're going to solve the equation square root of x squared minus 1 plus 3 equals x. Now whenever you have a radical equation, what you really want to do is get the radical all by itself on one side of equals. In this case, we do that by subtracting 3 from both sides. This gives us the square root of x squared minus 1 equals x minus 3. Now once you do that, you either square both sides, or if it's a cube root, cube both sides, and that cancels out the radical. In this case, we square both sides. We square the left side, and we square the right side. On the left side, canceling out the radical just gives us x squared minus 1. On the right side, x minus 3 quantity squared requires that we FOIL out x minus 3 times x minus 3. Some students forget to do that, and they just forget about those middle terms. But you have to do that. And this gives us x squared minus 1 equals x squared minus 6x plus 9. Now we have what looks like a quadratic equation, but when we subtract x squared from both sides and subtract 9 from both sides, the x squareds disappear and we end up with negative 10 equals negative 6x. Now divide both sides by negative 6 and we get 10/6 equals x, or 5/3 reduced. But we're not done yet. Radical equations always require that you check for extra solutions. In this case, we plug 5/3 into our original equation, and we get square root of 5/3 quantity squared minus 1 plus 3. Does that equal 5/3? Well, 5/3 squared is 9 or 25/9 minus 1. We can write that as 25/9 minus 9/9 inside the radical. We add the 3 to it, and 25/9 minus 9/9 is 16/9 added to 3. The square root of 16/9 is 4/3, and then we add 4/3 to 3. Well, 3 is the same as 9/3, and 9/3 plus 4/3 is 13/3, or 4 1/3, and that is not equal to 5/3. So here, even though we got an answer, it doesn't work. So the true answer to this problem is no solution. In the next example, we're going to solve an equation that has fraction exponents. Our equation is 3 plus 2x quantity to the 2/5 power plus 3 equals 7. Now the key to this type of equation is to get that fraction power isolated on one side of equals and then raise both sides to the reciprocal power. So we do that. We want to get rid of the 3, and we do that by subtracting 3 on both sides. That gives us 3 plus 2x to the 2/5 power equals 4. Now raise both sides to the 5/2 power, and that 5/2 power will cancel the 2/5 power, because you raise a power to a power, you multiply exponents, and the two reciprocals just multiply to 1. So we raise both sides to the 5/2 power, and we have to remember to use a plus and minus. This is because our original exponent, 2/5, had an even numerator. What we had here was an equation that was the equivalent of the 5th root of 3 plus 2x quantity squared. And any quantity squared equation, when you solve it, you're sort of extracting square roots, and that gives you the plus or minus. So just remember, if your original equation has an even numerator, you have to use the plus and minus. Anyway, now back to our equation. We take the 5/2 power both sides. We just get 3 plus 2x on the left, plus or minus 4 to the 5/2 on the right. And now we can solve this for x. We start by subtracting 3 from both sides, and then we divide both sides by 2. And that gives us x equals negative 3 plus or minus 4 to the 5/2 all over 2. And note that 4 to the 5/2 is equal to the square root of 4 raised to the 5th power, which would be 2 to the 5th, and that's where we get the 32 from in the next step. So x equals negative 3 plus or minus 32 all over 2. That gives us two solutions. Negative 3 plus 32, or 29/2, and negative 3 minus 32 over 2, negative 35/2. and we check both these answers. We plug them in. 29 halves checks out. We get 4 plus 3 equals 7. And negative 35 halves checks out as well. So these two answers are indeed our solutions. 29 halves equals x, and negative 35 halves equals x. In this example, we're going to solve a quadratic form equation. Our equation is 2x to the fourth equals 5 plus 3x squared. Because it has a constant term, an x squared term, and an x to the fourth term, it's quadratic form. Now usually what you want to do is get all the terms to one side. We do that by subtracting 5 and 3x squared from both sides. This gives us the equation 2x to the fourth minus 3x squared minus 5 equals 0. We're going to use the substitution method here. We're going to let x squared equal u, and you can see I color-coded it in red. And that means u squared equals x to the fourth, color-coded in blue. And now we do the replacements. We can switch out x to the fourth with u squared. We can switch out x squared with u. And this gives us a quadratic equation in u. Now let's say we just want to solve this with the quadratic formula. And maybe we don't see that it's factorable. Well, so let's solve it with the quadratic formula. We plug in the coefficients a equal 2, b equal negative 3, and c equal negative 5 into the quadratic formula, and we get u equals 3 plus or minus the square root of 49 over 4. A lot of students will stop here thinking they've solved. Well, no, they haven't completely solved. They've solved for u, but not x squared. We can evaluate each of these solutions. U equals 10/4 by replacing square root of 49 with 7, or u equals negative 1. Then we let each of these solutions equals x squared. So we get x squared equal 10/4 and x squared equal negative 1. We then extract square roots in each case, and we get two answers, plus or minus the square root of 10/4 and also plus or minus the square root of negative 1. Well, the plus or minus the square root of 10/4 simplifies to the square root of 10 over 2, and negative square root of 10/4 simplifies to negative square root of 10 over 2, because that square root of 4 turns into a 2. Plus or minus the square root of negative 1 meets the definition of I. We get x equal I and x equal negative I. And yes, we could have solved this equation by factoring.